Here, let's go over a couple of examples of finding the domain and the range of a function. So it's important that you remember, first let's talk about domain. Domain includes all of the x-coordinates of that function. So if you are given a graph like this and they say this is the function f and they want to know the domain, then we just want to know the x-coordinates of each of these points. So like this one right here has an x-coordinate of -6. So -6 is a part of the domain. This one has an x-coordinate of 0. So 0 is a part of the domain. This is +2, 4, and 7. So these are the x-coordinates of each of the points of this function. So you kind of put these sort of pointy brackets around it and say this is the domain. Now, if instead of points we have a line, the line consists of a series of points, right? They're all smushed together. So if you think about this, there are x-coordinates from here all the way to here. We're looking for what are the x-coordinates from here on the far left all the way to here on the far right. So you're basically looking at the graph and saying, how far to the left does it go? What is the furthest left x-coordinate? And that would be -6. And then how far to the right does it go? What is the furthest right x-coordinate? +6. So the x-coordinates of the points in between -6 and +6, like right here, this has an x-coordinate of -4. Right here, it has an x-coordinate of -2. Right here, it has an x-coordinate of 1/2. So it's all of the x's between -6 and +6. So we say the domain is in between -6 and +6, or x is between -6 and +6. So it is less than 6 and greater than -6. And since there's a solid dot on the ends, then that means it is equal to -6 and equal to +6. So we put less than or equal to signs there. Now let's look at the range. So the range is very similar to domain, but range is all of the y-coordinates. So if these points represent the function h, we're looking for the y-coordinates. So this one has a y-coordinate of 2. These have a y-coordinate of 4. This has a y-coordinate of -3. This has a y-coordinate of -2. So typically you put it in order, the numbers of your range in order from smallest to biggest. If more than one point has the same y-coordinate, you don't have to list it twice. Like we don't have to list 4 twice, we just list it once. So I would put the little squiggly brackets around it and say -3, -2, 2, and 4. These are the only y-coordinates in this function. And then similarly, if we're given a graph like this, the y-coordinates, remember the y-axis goes up and down. So we're looking for the y-coordinates of all of these points on this line, recognizing that there are an infinite number of points, an infinite number of y-coordinates that make up this line. So let's think, what is the very smallest y-coordinate that we see? How low does this go? It goes down to -3. This point right here has a y-coordinate of -3. And there's also ones with y-coordinates of -2, -1, 0, 4, 5, 6, 7, and so on. What is the very highest y-coordinate we have? Right here at 7. So you're basically saying, how low does our graph go? How high does it grow? It goes all the way down to -3. It goes all the way up to 7. And since we're talking about the range, we're looking at the y's. So the y's are less than 7 less than or equal to 7, and greater than or equal to -3, since we have a solid dot at both parts. If there happened to have been an open dot here, then we wouldn't say it's equal to 7. We would just say it's less than 7. But since it's a solid dot, I would put less than or equal to.